Hello everyone, welcome back to our Python Complete series. I am Sangamran and this is day 8 of our journey. In the previous video, we learned about functions, recursion, lambda functions, map, filter, and reduce method. Today, we are moving to one of the most important topics in Python because almost every world Python project use list. Whether you are building websites, AI applications, data science projects, automation, or game development, lists are everywhere. In today's class, we will learn how to create lists, how indexing and slicing work, every important list methods, nested list, and list comprehension. And finally, we will solve some interview style practice questions to make sure you understand everything. So grab your laptop, open VS Code, and code along with me. Don't just watch the video, practice every example yourself because that's the faster way to master Python. If you are enjoying this 15 days Python series, don't forget to like the video, share, and subscribe so you never miss the next class. So, without wasting any more time, let's start day 8 and master Python list. Hello everyone, welcome back to our Python complete course in series. I am really happy to see you back for day 8. If you have been following the series from day 1, give yourself a pat on the back because you are building a very strong foundation in Python. If you are new here, I highly recommend watching the previous videos first because every lesson in the course builds on the previous one. So before we jump into today's topic, let's quickly revise what we learned in day 7. In the previous class, we started with recursion. We started with recursion. Recursion is a technique. Wait for a second. Recursion is a technique where a function calls itself to solve a problem. We learned that every recursive function should have a base case. Otherwise, it will keep calling itself forever, eventually cause a recursion error. We called we solved examples like printing numbers, calculating factors, and generating Fibonacci series using recursion. After that, we learned about lambda function, also called anonymous function. Unlike normal functions that are created using the def keyword, lambda functions are short, single line functions. They are useful when we need a simple function for a short period of time without creating a complete function definition. Then we move on the three extremely useful built-in function. The first was map function. The first one was map function, which applies a function to every element of an iterable like a list. Next was filter function, which filters data based on a condition and returns only the elements that satisfy that condition. Finally, we learned reduce function, which combines all elements into a single result, such as finding the sum or product of a list of numbers. These three functions are widely used in data processing and functional programming. We also solved multiple practice questions where we used recursion, lambda function, map function, filter function, reduce function together. By now, you should be comfortable writing functions, passing functions and arguments, and solving problems using a functions programming approach. If any of those concepts are still confusing, don't worry. Practice the examples from day 7 once you again, because regular practice is the key to become confident in programming. Now it's time to move to a completely new topic, and honestly, this is one of the most important topic in Python. Today we are going to learn about lists. Let's think about this situation. Suppose you want to store the marks of 100 students. Will you create 100 separate variables, marks 1, mark 2, mark 3, like that, up to mark 100? that would be difficult to manage, update, and use. Python gives us a much better solution called a list, where we can store multiple values inside a single variable. Lists are used everywhere in web development, data science, machine learning, automation, game development, and almost every Python project you will ever build. By the end of today's class, you will be able to store multiple values inside a list, access elements from using indexing, modify list data easily, use important built-in list methods, work with nested lists, write powerful list comprehensions to make your code shorter and cleaner. So open your code editor, type every example along with me, and let's start mastering Python list. Now that we have revised the previous class, let's start today's topic list. This is one of the most important data structure in Python. Whenever you work on real world Python projects like web development, data science, and any other project, you will find that lists are used almost everywhere. So if you understand list properly, you will find many future Python topics much easier. Let's begin by understanding what exactly a list is. A list is a collection that stores multiple values inside a single variable. Think of a list as a container or a shopping bag. Instead of carrying one item in one bag and another item in another bag, you put everything in one bag. Similarly, instead of creating many variables, Python allows us to keep multiple values inside one variable using a list. For example, suppose you want to store your three favorite fruits. Without a list, you would write something like this: fruit one apple, fruit two like this, fruit one apple, fruit two mango, fruit three banana. This works for only a few values, but imagine storing 500 restaurant names or 1,000 product prices. Creating separate variables would become impossible to manage. That way, list saves us a huge amount of time. Now let's understand the important characteristics of Python list. First, lists are ordered. This means Python remembers the order in which the items are stored. If you insert apple first and mango second, and Python keeps them in the same order. Example like this. The order remains look always like this. Python never randomly changes this order. This is why lists are called order collection. Second, lists are mutable. Mutable means changeable. After creating a list, we can add new items, remove items, or even replace existing items. Unlike strings, lists can be modified very easily. We will learn exactly how to do this later in today's class. List allow duplicate values. Lists don't mind if the same value appears in multiple times. Example like this. If we print numbers and run the code, it will exactly, and list allow duplicate values. Notice that number 20 appears three times. Python stores every duplicate value. List can store different data types. Fourth point. This is one of the biggest advantages of Python. Unlike some programming language where every element must have the same type, Python allows different data types inside the same list. One list can contain integers, floats, strings, boolean values all together. Syntax of a list. Let's learn the syntax of a list. The general syntax is list name Syntax. Notice two important things. First, list are used square brackets. Second, every item is separated by a comma. That's all you need to create a list. Now let's see this in action. I am already written here fruits, apple, mango, banana. If I print fruits and then run the code, it will print apple, mango, banana. Let's understand this line by line. Here, fruits is the variable name. Inside the square bracket, we store three string values. The first string value is apple, second value is mango, third value is banana. When we print the variable, print fruits, Python print the entire collection exactly as is stored. Now that the output only appears inside a square bracket, that tells us Python is displaying a list. Example 2. Different data types. Different data types. Like it will store in one list. I will store integer also and float value also, Python string value also, and boolean value also. If I print data, oh, so sorry. Hmm. Then run the code. First, I comment out all of this and then run the code. It will print and 3.14. This single list contains four completely different types of values. The first value is 10 is an integer, the second value is 3.14 is a float, the third value is a string, fourth value is a boolean value. Even though these values have different data types, Python stores them together inside one list. This flexibility is one of the reasons Python is so popular. Summary and transition. So, what did we learn? A list is a collection that stores multiple values inside one variable. Lists are ordered, mutable, allow duplicate values, can store different data types together. Now that you know what a list is, the next step is learning how to create list in Python. There are several ways to create a list. Some methods are very common, while others are useful in specific situations. In this section, we will learn how to create a list, create an empty list. I write here how to create an empty list, how to create a list using list function, how to create list with different data types, how to find length of a list. Let's start with simplest one, creating an empty list. First, I remove comment out this empty list. It will look like that numbers equal to square bracket, and then we print numbers, then run the code. Python prints two square brackets with nothing inside them. This means the list exists, but currently it contains zero elements. Think about a school attendance register on the first day before any student's name has been entered. The register exists, but it does not contain any names yet. Similarly, an empty list is simply a container waiting to store data. Later, we can add values like this, like this. Then we run the code, it will print 10, 20, 30. Don't worry, if you don't know what append means, we will learn that in detail later when we discuss list methods. For now, just remember that an empty list is useful when data will be added later. Creating a list using list function. Python also provides a built-in function called list function. This function can convert many types of data into a list. Let's see an example here. Creating a list using list function. It looks like this, then print letter. Then we run the code, it will print Python. Now let's understand what's happening. The word Python is actually a string. When we pass this string into a list function, Python separates every character and it stores each character as an individual element inside the list. So this is so this single string Python becomes every character now occupies its own position inside a list. This is extremely useful when working with strings because sometimes we need to process every character separately. For example, checking vowels, reversing words, counting letters, or encrypting text. The list function is not limited to string. It can also convert tuples, sets, and other iterable objects into lists. But we will study those later in this course. For now, just remember that list converts iterable data into a list. Creating a list with multiple data types. One of the biggest strengths of Python is its flexibility. Unlike many programming languages where every element must have the same data type, Python allows us to mix different data types inside one list. Let's see an example here like that. Output of this is Rahul 2085.5 true. First name Rahul is a string, it stores the student's name. Then second 20, this is an integer, it stores the student's age, 85.5, this stores the student marks or percentage. And fourth true, this is a boolean value, it can represent information like a student is present, paid fees, a student passed the exam. Where true means yes and false means no. So a single list can store completely different kinds of information together. This makes Python very useful for handling real world data. For example, storing information about employees, storing product details. This flexibility allows us to organize related information inside one variable instead of creating many separate variables. Fourth is finding the length of a list. Many times we need to know how many elements are stored inside a list. Python provides the built-in length function for this purpose. Let's see an example here, like fruits and check the print length. This is the syntax for length function. When we run the code, the output is 3. Why is the output 3? Because there are exactly 3 elements inside the list. Let's count them: apple, mango, banana. Total 3. The length function counts only the numbers of elements. It does not matter whether the elements are strings, numbers, or boolean values. Let's see another example here. I will check in this also. Length, comment out this part and check the length of this. 4. Even though the data types are different, Python simply counts the elements. This function is used everywhere in programming, especially when working with loops and large data sets. Let's quickly revise what we have learned in this section. We create an empty list. We learned how the list function converts the string into a list. We saw the Python list can be multiple data types together. Finally, we use length function. Now that we have learned how to create a list, the next question is how do we access particular items from a list? Imagine you have a list containing 100 students' names. If you want to print only the 25th student's name, do you have a print the entire list? Of course not. Python allows us to access any individual element using indexing. If you have already watched the our strings chapter, this concept will feel familiar because list also use indexing just like a string. Let's understands how it works. First, what is list indexing? Every element inside a list has a position number. This position number is called its index. One very important rule to remember is Python indexing always starts from 0 to 1, 0, not 1. Let's take an example like apple, mango, banana, orange. Here, apple is stored at 0, mango is stored at 1, banana is stored at 2, and orange is stored at 3. Notice something important. Even though there are four fruits, the last index is three. That's why, because counting starts from zero. This is one of the most common mistakes beginners make. So always remember accessing elements using indexing. Index. We have to access first fruit. Then we have to write print fruit. Then zero. Then run the code. It will print apple. Let's understand line carefully. This list contains four elements. Now look at the first print statement. Print fruits 0. The numbers inside the square brackets is the index. Python looks at 0 index and returns the first element. Output is apple. You can access any element simply by writing its index number inside square brackets. For example, I write here 1. The output is mango. Python has another amazing feature called negative indexing. Instead of counting from beginning, negative indexing starts from the end of the list. Let's see how it works. Positive indexing starts, I write here. Notice that last element always has an index of -1. The second last element has an index of -2. The third last has the -3 and so on. Let's try it in Python fruits list. I write here -1. The output is orange. Python starts from the end of the list since -1 means the last element it prints orange. Let's try another example. -2. Then run the code. It will print banana. Negative indexing is extremely useful when you don't know the size of the list but need to access the last few elements. Modifying elements. One of the biggest advantage of list is that they are mutable. Mutable simply means changeable. After creating a list, we can replace any element. Let's see an example here. I write here fruit 1 equal to grapes. Then print fruit. The output will be apple, grape, banana, orange. Let's understand what happened. Originally, our list looked like zero apple, one mango, second banana, third orange. Then we were fruits one equal to grapes. Python goes to index one. The old values was mango. It replaces it with grapes. Now the updated list becomes apple, grapes, banana, orange. Notice that we did not create a new list. We simply changed an existing element. This is possible because lists are mutable. List versus string. List is mutable and string is immutable. This is an important interview question. Lists are mutable. That means you can modify, replace, add, or remove elements. But strings are immutable. Suppose we write name equal to Python. Suppose we write name equal to Python and name 0 equal to J. Python will produce an error because strings cannot be modified. If we write here print name, it will give an error for name 0. This is one of the biggest difference between these these two data types. In the previous section, we learned how to access one element from a list using indexing. But what if you don't want just one element? What if you want multiple consecutive elements? For example, suppose you have a list of 100 students and you only want to display students from position 10 to 20. Will you write 10 separate print statements? Definitely not. Python provides a powerful feature called list slicing, which allows to extract a position of a list e- very easily. Let's understand how it works. What is list slicing? List slicing means selecting a part of a list instead of the entire list. First, I comment out all of this and topic list slicing. Think of slicing like cutting a cake. You don't always eat the whole cake. Sometimes you only want a few pieces. Similarly, slicing lets us select only the elements we need. The general syntax of list slicing is like that. Here, start the index where slicing begins and the index where slicing stops. The start index is included, but the end index is excluded. This means Python takes the element at the starting index, but it does not take the element at the ending index. This rule is extremely important and is asked frequently in interviews. Let's see our first example, like numbers, like this. Output of this is 20, 30, 40. Let's understand this step by step. First, let's write the indexes. It will look like this: 0, 1, 2, 3, 4, 5. Then 10, 20, 30, 40, 50, 60. So first comment out this. Okay. 0, 1, 2, 3. Okay. Sorry. 3, 4, 5. Now look at the slice. Numbers 1 to 4. Python starts from index 1, so it's include 20, 30, 40. It ends It reaches index 4. Remember the index is not included. So Python stops before taking 50. That's why the output is 20, 30, 40. One of the best features of slicing is that the start and end values are optional. Like if I write print number only up to 3, then the output is 10, 20, 30. Here we did not specify the starting index. Python automatically assumes the starting index is 0 and stop before the index 3. The second example is Python 2 here. If you run the code, then say 30, 40, 50, 60. This times we omitted the ending index. Python automatically continues until the last element. Starting from 2, we get 20, 30, 40, 50, 60. There is another powerful feature in slicing called the step value. The complete slicing syntax actually, it looks like that. The step tells Python how many positions to move after each element. Let's see an example here. We use same list here, only comment out this and write here print numbers colon 2. The output is 10, 20, 30, 50, 10, 30, 50. Let's understand it. Since we did not specify the start and end index, Python starts from the beginning and goes until the end. The step value is 2, so Python skips one element every time. It selects 10, skips 20, selects 30, skips 40, selects 50, skips 60. That's why the output is 10, 30, 50. This is very useful when you want every second element at every third element or any regular pattern from a list. Reversing a list using slicing. One of the coolest tricks in Python is reversing a list using slicing. Instead of writing loops, Python lets us do it in single line. Like I write here -1, reversing a list using slicing. It will reverse the list 60, 50, 40, 30, 20, 10. Let's understand why it works. Starting index is omitted, ending index is omitted. Step value is -1. A negative step means Python moves backward through the list. So instead of reading from left to right, Python starts from the last element and moves forward to the first element. That's why the list appears in reverse order. This is one of the most commonly used Python shortcuts, and you will see it in interviews, coding competitions, and real world projects. So far, we have learned how to create lists, how to access elements, how to modify elements using indexing, how to slice lists. But list becomes truly powerful because of their built-in methods. These methods allows us to add data, remove data, or sort data, and reverse data and copy data. With just a single line of code today, we will learn the most important list methods that you will see almost every day as a Python programmer. Let's start with the first one, append method. The append method is used to add one element at the end of a list. Think of a queue at a movie ticket counter. Whenever a new person arrives, they stand at the end of the queue. They don't enter in the middle or at the front. The append method works exactly the same way. Let's see an example like this. First, comment out this. This is an example. If I write here fruits.append mango. and print fruit. What happened? Why it is not printing? Oh, sorry. I did not write here print fruit. Then we run the code. It will print apple, banana, mango. Initially, our list looked like apple, banana. After writing fruits dot append mango, Python added mango at the last position. The updated list become apple, banana, mango. Notice that only one element was added. If you call append again, fruit dot orange, here I write fruit dot orange also. It will print apple, banana, mango, orange. Every new element is always added at the end. Append only adds only one item at the end of the list. Then second is insert method. Sometimes we did not want to add an item at the end. Instead, we want to insert it at a specific position. For that, Python provides the insert method. The syntax is list.insert method syntax. Let's see an example with fruits.insert one at the orange. First, I comment out this and this also. Then I write here print fruits. If I run the code, it will print apple, orange, banana. Let's understand this carefully. Before insertion, 0 is apple and 1 is banana. We wrote fruits.insert at 1. Then Python insert orange at index 1. The existing elements automatically shift one position to the right. Now the list becomes 0 apples, first turn orange and second banana. This is useful when the position of the data matters such as ranking list, take priorities or menu items. Remember, insert function adds one item at a specific index. And third is extend method. Now suppose you want to add multiple item at once. Can we call append 5 times? Yes, but that's inefficient. Instead, Python provides the extend method. Let's see an example here. I write here print fruits, comment out this, and move this to here. When we run the code, it will print apple, orange, apple, banana, kiwi, grapes. Here we passed another list inside using an extend function. Python takes every element from that list and adds it to the end of the original list. Notice something important. If we write fruit.append kiwi grapes, the output would be apple, banana, kiwi, grapes. The entire list becomes one single element. Here, if I write look like that, here, so sorry. If I write this and then print the append function only, the entire list become one single element. It looks like another list inside a list, but extends adds each item individually. Notice something here, here. So remember that this difference. Append adds one item, extends adds multiple items. This is a very common interview question. Then move forward to remove method. Remove method. Now let's learn how to remove data from a list. This first method is remove function. This removes an element by value, not by index. Like I write here this and then print fruits and comment out this. If I print this, it will print apple, kiwi, grapes. Let's add this also. Orange also. And this here. Hmm. When we run the code, it will print apple, mango, orange, kiwi, grapes. Python searches for banana inside the list. As soon as it finds it, it removes it. If there are multiple occurrences of the same value, remove function deletes only the first occurrence. For example, I write here 10, 20, 30, 40 numbers. If I write here, oh, numbers dot remove 20 and then print numbers. If I run the code, the Python prints 10, 20, 30. Only the first 20 was removed. Remember, remove function removes by value and move to fifth point pop function. Another way to remove elements is the pop method. Unlike remove pop, removes an element by index. If no index is given, Python removes the last elements. If I write here fruits.pop, then print fruit. First, I have to comment out this fruit print function, then run the code. It will print 10. Oh, apple. Okay, sorry. Comment out this also. Then run the code. It will print apple, mango, orange, kiwi. It will pop the last view क्या था grapes था. It will pop the last word grapes. The last element grapes was removed. Now suppose we want to remove the element at index 1. I write the command like here I write 1 print and then run the code. It will print apple, orange, kiwi, grapes. First I write here print fruit, then run the code. Here Python delete mango from here. This prints the element that was removed. The remaining element automatically shift to the left. One interesting thing about pop function is that it is also returns the remove value. If I write here remove equal to source dot pop one, then print remove, then run the code. It will print mango. Mango is removed. This prints the element that was removed. Remember, remove by value. Remove function is removed by value. Pop function is removed by index. Then move forward to next is sort function. Often we need data in ascending or descending order. For this, Python provides the sort method. Example, I write here numbers 50, 80, 50, 20, 80, 10. If I write here numbers dot sort, then print number, then run the code. First, I comment out this, it will be confusing to you. If I run the code, it will print 10, 20, 50, 80. And here it is print 50, 20, 80, 10. It will give an ascending order. Python arranges the numbers from smallest to largest. Now suppose we want descending order. I will write here numbers dot sort and under bracket reverse equal to true. Then run the code. It will print it in descending order. Tells Python to sort from largest to smallest. The sort function method is also useful in strings. Sort arranges the elements in order. Move to another function, reverse method. Reverse method. Many beginners confuse sort function with reverse function. These two methods are completely different. Let's see an example. Numbers dot reverse here and then print numbers. Then run the code. It will print 10, 20, 50, 80. Suppose the list before calling reverse function was 80, 50, 20, 10. After reversing it will become 20, 20, 50, 80. Notice something important. Reverse function does not arrange values. It simply changes the current order. For example, numbers is equal to this. Then I write here numbers dot reverse and then print numbers. The output is 20, 40, 10, 30. The list is not sorted. It is no only reversed. So remember, sort arrange value, reverse change current orders. Eighth term is copy method. Copy method. Consider this program A equal to 1, 2, 3. If I write here B equal to A dot copy and then third line B dot append 4, then print A and print B. Run the code. It will here print 1, 2, 3, and then 1, 2, 3, 4. Let's understand it. First list contains A contains 1, 2, 3. Then we create a copy B equal to A dot copy. Now B becomes a completely separate list. When we add 4 to B, only B changes. The original list remains unchanged. Now look at another example here. A equal to 1, 2, 3 and B equal to A here, and then B dot append equal to 4. Then print AB and then run the code. Both will print A1, 2, 3, 4. Why did both lists change? Because B equal to A does not create a new list. Both variables point out to the same list in memory. That's why changes made using one variable appear in the another. To create an independent copy, always use copy method. Excellent. You have just learned the most important list methods in Python. So far, we have learned how to store numbers, strings, and different types of values inside a list. But what if one list needs to store multiple lists? For example, imagine storing the marks of an entire classroom, a timetable, a chessboard, or even a spreadsheet. In such situations, a normal list is not enough. That's where a nested list comes into the picture. Let's understand that what they are and how they work. What is nested list? A nested list is simply a list inside another list. In other words, instead of storing numbers or string directly, the elements of a list can themselves be lists. Think of it like a cupboard. The cupboard is one of the big containers. Inside the cupboard, there are several drawers. Each drawer stores different items. Similarly, the outer list is like a cupboard. The inner list are like a drawers. This allows us to organize related data in a structured way. Nested lists are widely used in tables, matrices, student records, Excel-like data, game boards, data science. Let's see our first example. Our first nested list is I write here. First, I comment out all of this. Here I write matrix equal to first list and then 1, comma 2, comma 3, then comma second list under list first list and then second list is 4, comma 5, comma 6, then comma, then 7, comma 8, comma 9. If I print here, print matrix, it will print 1, 2, 3, 4, 5, 6, 7, 8, 9. The variable matrix contains three lists. The first list is 1, 2, 3, the second list is 4, 5, 6, the third list is 7, 8, 9. All three lists are stored inside one larger list. This is exactly what a nested list look like. You can think of it as a 3 cross 3 matrix table. This type of structures is called a matrix, and you will see it frequently in mathematics, machine learning, and data science. Accessing elements in nested list. Accessing elements in nested list is slightly different from another list. Since they are list inside a list, we need to indexes. The first index selects the inner list. The second index selects the element inside that inner list. Let's see an example. If I write here print matrix at 0, it will print 1, 2, 3. What happened here? The index 0 points to the first inner list. So Python returns 1 to this. Now suppose we want only the number 6. Then I write here one first and then second. Python prints 6. The first index matrix 1 thus selects the second row 4, 5, 6. Now Python looks at the second index 2. Inside that row, index 2 contains 4, 4 index 0, 5 index 1, 6 index 2. So the final output becomes 6. Always remember, first index select the row innerly, second index select the inner element inside that row. Let's look at a more practical example. Suppose we want to store student names along with their marks. Like I write here, students equal to matrix list, and then another list I created inside that Sangam, comma 85, Simran 92, then Aryan here 88. Here each inner list store information about one student. First student Rahul, first student Sangam 85, second student Simran 92, third student Aryan 88. Now let's print only the third student's name here. Here I write print students, then 0, 1, 2, 2 here, then second 0. The output will be Aman. If I write here 1 and then print, our output will be Simran. First, stop this printing, then this also, then output is Simran. First index students equal to 1. Select the third, select the second student's record that gives us Simran 92. Now the 0 selects the first element of that record which is Simran. Similarly, if you want the third student's second student's marks, you can write here students 1 comma 1, then run the output. Marks is 92. This shows how nested lists help us store and organize related information together. Instead of creating separate variables for names and marks, we can keep everything neatly grouped. So far, we have learned how to create list, access elements, modify them using list methods, and even work with nested lists. Now it's time to learn one of the most powerful and elegant feature, list comprehensions. If you have ever written a loop to create a list, you will love this feature because it lets you write the same logic in just one line of code. It makes your code shorter, cleaner, and more Pythonic. Let's understand what it is. What is list comprehension? List comprehension is simply a shorter and smarter way to create a list. Instead of writing multiple lines using a for loop and append function, we can create an entire list in a single line. This saves time, reduces the amount of code, and makes your programs easier to read. However, before learning list comprehension, the traditional method, normal method using for loop, Suppose we want to create a list containing the squares of numbers from 1 to 5. The traditional approach is squares, bracket, and then for I in range, and then square dot append I into I, and then print the squares. This is the traditional method. I am showing you here. It will look like this. Here I write here print square. Then run the code. It will print 1, 4, 9, 16, 25. Let's understand it step by step. First, we create an empty list. Then the loop starts for I in range 1 to 6. The value of I becomes 1, 2, 3, 4, 5. For every value, we calculate I into I. So Python calculate 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5, 25. Each result is added to the list using append. Finally, the list becomes 1, 4, 9, 16, 25. The method works perfectly, but it requires several lines of code. Can we make it shorter? Yes. List comprehension. Now, let's solve the problem using list comprehension. If I write here instead of this, if I write here this line and remove this also, and then print squares. It will print the same 1, 4, 9, 16, 20. Look at the difference. The previous solution needed an empty list, a loop, and the append function. With list comprehension, everything happens in one line. Python still performs the same work. It takes number of from 1 to 5, calculate their sequence squares, store each result in a new list. The output is exactly the same. So list comprehension does not change the result. It simply makes the code more concise and readable. List comprehension becomes even more powerful when we add a condition. Suppose we want to create a list containing only even numbers from 0 to 19, like this. If I print right here, print even, then run the code. The loop runs through every number from 0 to 19. For each number, Python checks the condition I is modulus of 2 equal to 0. If the remainder after dividing by 2 is 0, then the number is even. Only those numbers are added to the list. Only numbers are ignored. Odd numbers are ignored. This allows us to create This allows us to create filtered list in a single line without writing a separate if statement inside a loop. General syntax of a list comprehension is like syntax is like that. Expression, the value you want to store in the new list item, the variable that represent each element. Iterable, the sequence you are looping through, such as a list range function. If condition, an optional condition that filters which elements are included. Then last, I am giving you some practice question and homework question. You have to practice in your by your own. I write here practice questions. Practice question one. Create a list of 5 fruits. Question to print the second and last element. Practice 3. Replace The third element with Python, practice, practice 4, right here. Oh, sorry. Fourth question is this: create a nested list of three students and their marks. And practice question 5 is create a list of square from 1 to 10 using list comprehension. This. And then homework questions. I am giving you 5 homework questions. First, create a shopping list and perform append, insert, remove, pop. Create a second question, create a list of numbers and print maximum value, minimum value, and sum of all numbers. Question third is reverse a list without using reverse function. Question number 4, create a 3 cross 3 matrix using nested list and print the center element. And question number 5, last question, use list comprehension to create a list of all odd numbers from 1 to 50. Congratulations, you have completed day 8 of the Python complete series. Today we learned list indexing, slicing, power list, full list method, nested lists, and list comprehension. These concepts are used in almost every Python project and coding interview. Practice today exercises before moving ahead. In the next class, day 9, we will learn tuple sets dictionaries. If you found this video helpful, don't forget to like, share, subscribe, and press the bell icon so you never miss the next lesson. See you in day 9. Goodbye.